All right, we're going to get started here with our next speaker. I heard Rolling Stones playing, and a couple people asked if I would do my Mick Jagger dance for the next 5 minutes. So if you don't take a seat, you're going to have to watch me do the Mick Jagger. All right. So next up, we have Dr. Paul LaViolette, an accomplished man, and he will be speaking on reverse engineering the U.S. secret aero propulsion technology. So if you would, give a warm welcome to Dr. Paul LaViolette.
Very happy to be here. I grew up in a family of scientists. My father was a nuclear engineer, my uncle aerospace engineer, and at a very young age I was interested in space travel, read avidly science fiction books, began working at one point on a physics theory, a new approach to physics, which I've come to call subquantum kinetics. And that's what got me into the whole area of electrogravitics and space propulsion. It was through that path. And so today I'll be talking about reverse engineering of past technologies that have been kept secret, which my purpose, I guess the motivation, has been to get these out in the open, to try to reverse engineer them so they're no longer secret, because we desperately need these to improve society. I believe the world would have been a completely different place if we had these technologies today. It would be much more idyllic, paradisical society. I believe technologies can, by making the world more prosperous, bring more peace to the world. And but first, before going to these past technologies, I'd like to talk about a technology that is newly emerging now that's not classified, and related to our mission to Ceres recently, which is in the news. It's still going on. Ceres is a small body in the asteroid belt. It's 945 kilometers in diameter, and there are these strange bright spots that they found on the surface in this crater. And here's a close-up. This is taken at an altitude of 1,470 kilometers. The crater itself is just 92 kilometers in diameter. And this is puzzling. Scientists don't really understand what it could be. Some have suggested ice, others salt. I have wondered, could it possibly be light reflecting off of enclosures, some camp or outpost that's been established there? Because if, let's say, there were domes, they're going to reflect light more than the surrounding surface, and so you would see illumination like this. And here I compare, on the left, the Ceres bright spots to Grand Rapids, Michigan, on the right. This shot of Grand Rapids taken from an altitude of 400 kilometers. Now, Grand Rapids has a population of 190,000 approximately. Its size 23 kilometers. On the left, if you scale it, 9 kilometers, just the left bright spot is 9 kilometers. in diameter. So you could say, perhaps, if it was like Grand Rapids, you could even have as many as 50,000 people living there. And we'll know more about these by the end of December. They're supposed to be a lot lower in their orbit. This is the Dawn spacecraft. And they'll be, I guess, even early December, down to 375 kilometers, about the height of the space station that was taking the Grand Rapids picture. And this is the Dawn spacecraft that NASA has sent out there. It's taken 7.5 years to get out there. Uses ion thruster technology, xenon ion thruster. The reason they use this technology because it's more efficient than chemical rocket technology, because with this, they use solar cells to get the energy from the sun, and they use that to electrify xenon, split off its electrons, and accelerate it in an accelerator, and create this ion exhaust that you see here. It's an artist's conception. This way, they don't have to take their energy supply with them. They take the energy from the sun, so it ends up being more efficient in that sense. But they still need fuel. Approximately half of the spacecraft weight is xenon. Spacecraft weighs 1.2 tons, and the xenon is about half a ton they have to take with them. So now I'd like to suggest, how about instead of taking 7.5 years to get there, going there in 2 weeks, or even journeying beyond? Suppose we send a probe to Alpha Centauri or Epsilon Eridani. I'd like to introduce the Nausicaa superconducting thruster. It was invented by Professor Athanasios Nausicaa of the Technical Educational Institute of Larissa in Greece, and he received a patent this year. I met him a few years ago at a scientific conference and have been helping him on testing this and patent applications, making contacts with NASA and other organizations. It weighs about 118 grams, can fit in the palm of your hand. It consists of a superconducting nozzle. This is a cross-section view here. This is the superconductor. It's a high-temperature IBCO superconductor, so it's superconducting at liquid nitrogen temperatures. And it has a permanent magnet in its throat. And this requires no energy, and it's able to develop a force on the superconductor. It develops about a little over 2 grams of force. That's about the weight of a half of a sheet of paper. But this is enough that if you put this in space, it would accelerate with about 2% of the Earth's gravitational acceleration. The magnet is about 1 Tesla. The strongest permanent magnets we can make are around 1.4, slightly over 1.4 Tesla. There are stronger magnets, but only for military use, and you wouldn't be able to buy them. Now, in space, the temperature is can get down to 40 Kelvin. That's 40 degrees above absolute zero, if you have a sun shield to shield the sun. Now, so you wouldn't need any cooling for this in space. And it's possible, now we've tested this in liquid nitrogen, but in space, going down even to lower temperatures, because liquid nitrogen is at 77 degrees above absolute zero. Going to 40, we believe that it would develop even more thrust. And who knows, maybe it could even develop as much as twice the Earth's gravitational acceleration. We don't know. Maybe that's way too much, but this is something we'd like to see, how this thrust can be improved. And this is an experiment I'll show you next. It was performed, it's an excerpt from a video we took at Athens University last year. And it shows the thruster moving. It's a pendulum test. And you see how it moves to the left. And we have a reference plumb line behind it, so you can see that it's always to one side. The reason why it's oscillating is it tends to overshoot its equilibrium. Okay, so it's a very short section. The reason I showed this is because it's hanging in the air, so you can't make any claims that the liquid nitrogen bubbles or something are affecting it. We also have videos of it in the liquid nitrogen bath doing the same thing. Also hanging the bath itself and the whole box moving to the side. Once it warms up and it's no longer superconducting, it stops moving, just hangs plumb. So this is an example of reactionless propulsion, and there's a whole array of inventions that deal with reactionless propulsion, even though they violate major law of physics, which is called Newton's third law. And now, subquantum kinetics, which is the physics that I use to interpret these various devices, it holds that the magnetic field is seated in the surrounding ether. So when you have that magnet that's attached to the superconductor, it's producing a magnetic field, but the magnetic field is not attached to the magnet. As in standard physics, physicists might think, well, the magnetic field has to somehow be attached to the magnet. When you begin with the idea of ether, or you can call it a quantum vacuum or material vacuum, that there's something there in the ether, that the fields are in that, then the field can exert forces on the superconductor without owing anything to the magnet that created it. And in this case, the field produces unbalanced forces on the nozzle. I'll show you in this picture. The magnetic field from the magnet is going to be stronger inside the throat than outside, because the field has to go all the way around here so it spreads out. So it's exerting a force on the superconductor, which is called the Meissner effect. Now, when a material becomes superconducting, it expels all the magnetic field lines from inside itself, and then at that point, the magnetic field outside ends up exerting pressure on the superconductor, a force. It's called the Meissner effect. It's the same phenomenon that's involved in maglev for moving trains. So it turns out there's this unbalanced force where inside it's greater than outside. And if you analyze, because of the slope here, you can analyze it into two components. The component radial to the axis, perpendicular to the axis, is going to cancel out, but this component will end up in a net thrust, which pushes it in the direction of the convergence of the nozzle. And you can think of it this way. This is one of Townsend Brown's thrusters, electrostatic thruster. It's asymmetrical capacitor. And in his thruster, you notice that you have the same amount of charge on both poles, but here it's spread out more. So the force is pushing. You see, this is positively charged, so the positive field that is created here is going to repel downward. But because the field is so spread out, it's going to be a weak repulsion downward. Here, the charges around it that are hanging around here, that field is going to create a very strong force on this. It's the same amount of charge, but it's more concentrated, and the field's more concentrated, so you're going to generate very strong force upward. Now, in standard physics, they would say, okay, all this will do is generate a stress on the structure, because they think of the field as somehow attached to the capacitor plates. In subquantum kinetics, when you admit there's existence of the ether, you realize that these forces are anchored in the ether, and therefore when you have an imbalance, it will end up in creating a net propulsion, and this is what Brown demonstrated. And the same thing is going on with the Nikola thruster. Now here, I compare it to the spacecraft thruster, the Dawn spacecraft. On the left, it's about 30 centimeters in diameter, whereas Nikola thruster is only 5 centimeters diameter. And about 5 Nikola thrusters are equal to the Dawn spacecraft thruster in terms of the amount of thrust it produces. And here I compare them. And what's important is the thrust to mass ratio. How much thrust it produces compared to how much it weighs. So with the Dawn spacecraft thruster, you have to not only include the weight of the thruster itself, which is around 15 kilos, but also the fuel, the xenon, you take along with you, which is almost half a ton, and the weight of the solar cells, another 10 kilos or 15 kilos. And when you do the ratio to get the thrust to weight ratio or thrust to mass ratio, it's right here, down here. You see that this is the N-star thruster on the Dawn spacecraft. In terms of newtons per kilogram, it's 1,000 times less than a Nikola thruster. So Nikola thruster puts out 1,000 times more thrust for the same amount of weight. Another thing is the Dawn thruster takes about 2.3 kilowatts to make it operate. The Nikola thruster requires no power input. Nikola thruster has an infinite efficiency or infinite thrust to power ratio. And it's not limited how far it can go, whereas the Dawn thruster, it only can go as far as its fuel will take it. When the xenon runs out, then that's it. So they refer to that specific impulse, 3,200 seconds. It's what they rate it at. So now, let's say we reduce drastically the weight of the Dawn probe. Instead of 1.2 tons, now we can make it 35 kilograms with all the miniaturized apparatus with cameras and telemetry and everything, and gyroscope, whatever is needed. With the Nikola thrusters, which add hardly any weight, 600 grams, to deliver the same thrust as huge Dawn thruster would deliver, we can now accelerate 35 times faster than we could before. And if the Nikola thruster develops higher accelerations at lower temperature, like we're suggesting, maybe it could even go up 3,500 times more acceleration. So instead of going to Ceres in 7.5 years, we can make the trip cruising at a speed of 140 kilometers a second in less than 1 week. and at least to get up to speed in 1 week, excuse me, and make the entire journey in just 2 to 4 weeks, because we have to, when we get halfway there, then we have to decelerate. We have to turn this thing around, decelerate. So we have 0 fuel weight and 0 power consumption. Now this, it violates also the first law of thermodynamics, the idea of energy conservation that physicists hold to, and they use this to claim that perpetual motion is fraudulent, and they use it to throw people in jail and suppress a lot of free energy technologies. So this blatantly violates that, and the nice thing is you can take this into any physics classroom, put it on the table, demonstrate it, and you've violated a major underpinning of physics theory, of standard physics. So I don't think that, we haven't gotten many invitations yet. So it is, however, explained in subquantum kinetics, which holds that the universe operates as an open system. So that, in other words, that there's more than the physical, that there's a unseen reality that we've been told about from mystical traditions, from religion, which is actually more real than what's here. If you think we're like the watermark on the paper, and the paper is the real substance, but we can't see it. It's the etheric, it's space. Now, the question is, where does the energy come from? Well, it's the magnetic field that's generating this pressure, but what causes the magnetic field? They say, well, it's produced by electron spin. The spins of the electrons and the magnet are all aligned. That leads to the question, where does spin come from that electrons have? The physicists consider it as an innate property of the electron, just like charge and mass. But they never really explain they don't explain how is charge produced, how is mass produced of particles, how is spin produced. These are just givens. But these are the important questions. Unless you answer these, you're in the dark. And subquantum kinetics answers these. To get into subquantum kinetics, very involved, and it requires a big shift. I mean, you'd have to throw out most of physics concepts, both in cosmology, quantum mechanics, and so on, which it would take time for people to do that, to go through that whole process. So you could say, to summarize, so you don't say, well, geez, this is his theory, should I believe it or not? Say that it comes from space, this energy coming from space. The space is active, and that the spin is active because of space. And in subquantum kinetics, we should not take for granted the fact that objects remain in existence. In subquantum kinetics, there's a prime mover that underlies all existence, which if it were to stop, everything would just dissipate. And that's the energy source. That's the ultimate energy source that we tap into for most of this. And it flows through our universe continually. So our universe is like an open system. And with open systems, as physicists will acknowledge, open systems can increase order. You can have the generation of energy, because that's just a small ripple in terms of this huge torrent of energy that's underlying everything. And I believe even Tesla was referring to this concept. It's an ancient concept. Heraclitus was talking about it, that the universe, we're like in a river, flux. Everything is in flux under us. This is a depiction in subquantum kinetics. So the G, X, and Y these are ether states. And imagine that all physical phenomena, electric and magnetic, electric, gravitational fields, they're made out of these three states. And there's other ether states upstream that you have transmutation of one ether state into another, progression, just like an evolution of states. You have also interactions, reactions. So you're taking concepts from chemistry, you're bringing it into physics in subquantum kinetics. So you see from this that then there's an outside to the universe. There's, realms which are made of different ether states that are not here, you know. And this is what a subatomic particle would look like in subquantum kinetics. You have X and Y are two ether states, and this is depicting concentration. The core of this particle, in this particular case, this would be a positively charged particle, where the core has high Y, and its outer shell from there, it has high X. So these alternate, like where Y is high, X is low, and then X is high, Y is low. And this is sort of like yin and yang concept. In fact, the yin-yang metaphysics is brilliantly depicting the essence of the subquantum kinetics physics. This is very ancient, by the way. You see it in a lot of the ancient myths encoded. And here, this is the idea of spin, that if you had this where you have differences from the core to the shell, you're going to have these exons or yons flowing from the high to the low area. This is a simple idea of diffusion. And these radial diffusions the idea is they can create a vortex. And I believe this is what spin is. So spin can be traced to this radial pattern, and this is not just theory. After subquantum kinetics predicted this, they did experiments colliding particles in Virginia, southern Virginia, and found that the proton and neutron, their electric charge had a wave character, just like this, with the wavelength the same as what we were predicting, subquantum kinetics. Now, here, this is to just demonstrate that the idea of violation of energy should have been known for years in the Meissner effect, the maglev idea that operates, it's been shown. Here's a video.
To do with this permanent magnet is I'm going to place it on top of the superconductor. Okay,
from
so
YouTube.
It's just on top of the superconductor. It's not levitating. It's not doing anything. It's not moving. Okay. Now, what I have here is liquid nitrogen. It will boil off pretty rapidly at first until it cools down the superconductor. So it will spit and so on. So just sort of keep your eyes back, please. Now it'll take, as it boils off, it will cool down. Now just watch what happens. Can everyone see? So it's cooling it down. So it's levitating.
It produced work just then.
If it was pushed up, there's no magic involved. I didn't touch it. So as you can see, whoops.
Oh, that is nuts.
Okay, so
Yeah. Okay, so this is an experiment physicists have done repeatedly, and spontaneously work is produced. The magnet is lifted. That's work. Where did the energy come from to do that? You know, the thing is cooling off, which means heat flows out of it. Energy is not flowing in, it's flowing out. Why does this lift? And once it's lifted, why does it stay up there? What continual energy source is keeping it up there? So these are things we take for granted, but we shouldn't, because these are important phenomena that would change our concepts that we're being taught. And here's the maglev train in Shanghai. So thousands of people ride this every day, and they're violating the first law of thermodynamics routinely. So what I'm saying is it's not that unusual what's happening in that Nasica's thruster. The only difference is it's the same maglev, except instead of having the magnet separate from the thruster, Nasikas has figured out to put it on the thruster. He came to this idea through a theory he was developing, approach to physics he calls minimum contradictions theory. And this theory led him to postulate that this was possible. Also, he is an analogic thinker, takes ideas from one field, brings them into another, and he noticed that the laws of fluid mechanics are similar to magnetics. And so he could think of this in terms of fluid mechanics, like a garden hose with a nozzle. The water pressure, if the nozzle's not attached, is going to go flying off. It's the same idea. So now, suppose we use this for interstellar trips. What is the best that NASA has proposed? They have the idea of the solar sail that they were talking about, but they eventually abandoned it. Now, with the solar sail idea, they would start near the sun and deploy the sail, and it would take 16 months for the sun to push the sail and the probe out to reach Jupiter. By that time, it would be going 70 kilometers a second, and at that point, they would discharge the sail and keep coasting, because now they have no more propulsion. They're going just coasting at that speed. And it would take them 15 years to reach a distance of 200 AU. AU would be astronomical units, the distance between the sun and the Earth. So 200 AU, you're outside the solar sheath, the heliopause sheath. You're then in interstellar space. So this would be for a mission to go see what's out there in interstellar space near the sun, near the solar system. Now, if that was to continue at that speed, it would take 18,000 years to get to Proxima Centauri, the closest star, which is about a little over 4 light years away, going at 70 kilometers a second. So it's not very practical. I mean, if they launched this, nobody would ever know it 18,000 years from now. Now, with the Nasica's thruster, you put it there, and this is that pitiful little thing you saw demonstrated. This is not, let's just say that it develops 5 times that thrust at lower temperatures. In 21 days, you've reached Jupiter instead of 16 months. Your velocity is 10 times greater than what the solar sail had developed. But it continues to accelerate. By the time you reach 200 AU, less than 5 months later, you're out at 200 AU, not 15 years, you're at 1.6% the speed of light. And then by the time after about 10 years, you're at 42% the speed of light. At that point, you turn it around, you decelerate. So in 20 years, you've reached your destination, and you can relay your information back using the energy from the sun there. Take about 4 years for those radio signals to reach us. So that's within a person's lifetime. So suddenly we have a possibility to send a probe to the closest star. We could suppose the probe weighed 150 kilograms, which is reasonable, and The Nasica thruster to do this would take 1,000 thrusters, and they would increase the weight to 270 kilograms, which is about the same weight as the NASA interstellar probe. So this would transform, if this was put, and that's just something we have today, that would completely transform NASA's space program, and we're trying to interest NASA. And I tell you, it's not an easy task. You have to, there are people, we've shown this video to many people, and they have trouble believing that this is not due to air currents or bubbles or something like that. NASA has tested, or at least a small group in NASA tested a reactionless propulsion device called the EM Drive, and this was in the news about a year ago or so, which uses microwaves in a conical enclosure, and it develops asymmetrical forces, unbalanced forces, which end up propelling it in the direction of its large end. This is the opposite from the Nasica's. Nasica's thruster would tend to go towards the convergence direction. But even here, Nasica's thruster does better. Its thrust to mass ratio is 10 times, 10 times better, has 10 times more thrust for the same mass. It doesn't require any power, so this would never make it to Alpha Centauri because you don't have any solar source along the way. Nuclear wouldn't last. We see this as better technology. Now, there's also another version of the Nasica's thruster, call it Nasica's thruster 2, which has not been tested yet, but predicted that this should be possible. And that uses a superconducting coil. And here you see on the left a cross-section view that if you take a coil like this, superconducting coil, it's been developed at the National High Magnetic Field Laboratory in Florida, and wind it so that it's slightly conical, you get, now this will produce forces around 2.5 Tesla, and there'll be huge currents in the windings, because when the way you energize a coil, you dump a lot of electric power into the coil, it creates this current, and you can seal it off, and that current will go forever, generating that field. Zero resistance. But that current is going to interact with the magnetic field it's producing according to Lorentz equations. It produces what's called the Lorentz force. And if you look at the direction, that force is outward. But because it's sloped here, it's perpendicular here, there's one component that goes this way, which balances on each side, but this component is unopposed, and it will cause a lift. And we did a calculation on this. And we were low-balling it. We weren't trying to be real exotic. We could get 130 kilogram thrust out of a coil only this big, which would weigh 4 kilos along with the liquid helium to cool it. That's a thrust-to-weight ratio of 32, which is 20 times what the Space Shuttle main engine does. Space Shuttle main engine just has a thrust-to-weight ratio of 1.5, and just enough to get it off the ground, actually, initially. With the Space Shuttle, the rocket fuel to get the Space Shuttle up there weighs 20 times what the Space Shuttle weighs. Now, with the Nasica's thruster, the thrusters required to lift the Space Shuttle would weigh only 5% of the weight of the Space Shuttle. So on the left is the way we were doing it, and most of the weight is in the rockets to get up there. With the Nasica's thrusters, you could just put these in the under wing here, and it would take off this way. And just a slight increase of the weight, 5% of the total. Yeah. You wouldn't have to worry about tiles or friction of entry, all this. You could come down just slowly through the atmosphere. You wouldn't have any Columbia disasters or anything. So we have to build this and test it. It takes about $20,000 to build one of these. And Nausicaa is quite certain that it will work as he believes. So this would completely revolutionize also air travel on Earth. So not just space, but Earth. The hoverboards in Back to the Future could be possible. Who knows? So to go to the earlier technologies, it's in my book, Secrets of Antigravity Propulsion. Many of you have probably seen Ben Rich's quote. He was head of Lockheed Skunk Works, and in January of 1995, I guess at that time he had cancer, and so he was a little open in his comments. He said, "We already have the means to travel among the stars, but these technologies are locked up in black projects, and it would take an act of God to get them out to benefit humanity." Well, fortunately, Townsend Brown was doing his work well before a lot of the secrecy clamped down on all this. He was born in 1905 in Ohio. And as a boy, he wanted to go to Mars. And at the early age of 10, he was working in a laboratory. His parents were quite well off, and they saw his interest in science and encouraged it and allowed him to have his own well-equipped laboratory. And he found that putting high voltage, 50,000 volts, on a Coolidge tube, an X-ray tube, would cause it to move. And he thought that this could be a way to get him to Mars. And so he developed what he called a gravitator, or gravitator. It's a capacitor, and this is from one of his patents. It consists of layers of plates, capacitor metal plates with insulators between them, but loaded with lead to make them heavy. And he found that when he charged this, it would move towards the positive electrode side. It would develop a gravitational force electrically. And on the right, we see a setup where he mounted this from the ceiling, and this merry-go-round would rotate when he'd energize it. And he was doing this in high school. And here he also hung this as a pendulum from the ceiling to do linear displacement. And here he was testing in oil. The oil would prevent a lot of ions from being emitted, because this is one of the criticisms some people were making, saying, oh, this is just the repulsion of the ions around your device. Here he eliminated that, and still he saw motion. In fact, this was supposed to work underwater, too. So in 1922, he entered Caltech. Now, he was then only 17 years old. He took his equipment with him, and he set it up one day, wanted to open to professors there to get them interested in what he was doing. And he was hoping Millikan would show up, Nobel laureate there. And you can imagine Millikan, 17-year-old, he thinks he's kind of outsmart Einstein, so he never showed up. And this crushed Brown. And he thereby decided Caltech was not for him, and he transferred to Kenyon College in Ohio. Not a big name, but at least they were more open-minded. Then he transferred to Denison in Ohio, where he befriended physics professor Paul LaViolette, who supported his work. And from 1926 to 1930, he worked in his own private laboratory. In 1928, he submitted to Physical Review, very well-known physics journal. They rejected his paper because it challenged Einstein's theory. Shortly afterward, he received a patent on his technology, on this electrogravitics technology. I guess he wanted it to be public, so just in case patent would be classified, he published in a non-technical journal called Science and Invention Magazines, equivalent of like Popular Mechanics or Popular Science. And this is the cover of that August 1929 issue. And here's what his article looked like. That's a picture of him on the left. And here I quote one part of the article in there where he says, any system of two bodies possesses a mutual unidirectional force in line with the bodies, which is directly proportional to the product of the masses, directly proportional to the potential difference, and inversely proportional to the square of distance between them. It's almost, he's quantifying this. It's electrogravitics phenomena. And so this is not rocket science. This is, it's a little more complicated to understand, but rocket is simple to understand for, at least in the physics framework. Maybe it's simpler when you get out of the physics framework and you explore new alternatives. So like the Nasikas thruster, Brown is violating the Newton's third law, produces action without reaction. General relativity is unable to explain this because general relativity assumes that you can only have gravity wells. Only masses can produce gravity wells and they attract. It predicts no connection between charge and gravity. And Einstein was scratching his head till the day he died to try to come up with a way to bring a connection between the two to make a unified field theory. He never was successful. I believe he was aware of Brown's work because during World War II, Brown was entrusted with $50 million for a project, had something like 50 PhDs under him. The cover is that it was for mine searching during World War II. In my book, I talk about the belief that that was actually the Philadelphia project, and Brown was a key player in that. He's been asked directly by William Moore if he was involved because of the rumors, and Brown did not deny it. He just said that much of what's written about the Philadelphia project or Philadelphia experiment is not true. So that's all he would say. So maybe he was referring to time travel and that sort of thing. So subquantum kinetics does predict this connection between charge and gravity. I published the first journal publication on it in 1983 in the General Systems, International Journal of General Systems. They broke it up into 3 papers. It was a very long paper. So they made 3 papers, and then they decided, well, we'll make a special issue. So the whole volume was on subquantum kinetics. And they put somebody write a preface. And in 1994, I came out with the first book, which was basically expanding on the original publication. And it's gone through 4 editions. The latest is the 4th edition, which is an ebook, which if you buy the 3rd edition, which is out there, you get the 4th free. And if those are sold out, you can order through etheric.com, all of these books that I have out there. So in subquantum kinetics, it predicts the particle would look like this, the electric field of the particle. In this case, we have positive and negative, matter and antimatter, right? So here, this would be depicting a proton where Y is high in the middle. Here we're plotting just the Y ether concentration, or Y potential, because you can express this in terms of potentials, etheric potentials. I developed some terms in this physics. And for a positively charged particle, like the proton, it would produce a G-well. But the negatively charged particle, if this was an antiproton, would produce a G hill. Or in the case of an electron would produce a G hill. And so then, if you look at Brown's experiment with the dielectric, the capacitor, which consists of two metal plates with an insulator between them, what it does is it separates the charges, the plus on one side and minus on the other, and that would then create a G hill on the left and G well on the right, and this gradient would act like a gravitational gradient, just like the Earth is creating a gravitational gradient, which pulls us down. So here, this is artificially engineered. It's as if you took a mountain, shrunk it to the size of a cannonball, and placed it just outside the positive plate. So that force is going to tug this. So it's a huge gravitational force you're producing. You know. So Brown was able to get about 1% of the force compared to the weight of the capacitor to show the pendulum swing. This is just some points about subquantum kinetics. Been in existence for 30 years. It's based on concepts come out of non-equilibrium thermodynamics, systems concepts, chemistry, chemical kinetics. It's made over the years 12 predictions, which were subsequently verified. So at this point, I really believe it. You know, in the beginning, I was being tentative about it, even afraid. One of its predictions was this charge electrogravitic effect. And when I learned about Brown's work in 1985, I was thrilled because here was a confirmation of what the theory was saying. And there's been other confirmations since that time, which checked out. It's a unified theory, unified field theory, that acknowledges the reality of the ether. It conforms to Tesla's ideas. Really, and I wasn't reading up on Tesla when I created it. Later, I discovered the parallels. It also fits with ancient concepts, Eastern concepts of the ether. It unifies physics with the life sciences and with esoteric thought. So if you wonder why physics has gone astray, it's the most far removed from our direct perceptions because it's at such a small level what's going on. And there's what they call Heisenberg uncertainty principle, that you can never really know the position, momentum, energy of a particle at the same time. So they operate in sort of observational fog, so it's very theory-oriented and checked with observation, but there's a lot of observations that contradict the theories, and they are conveniently swept under the rug. You don't find this in biology. There, you know, it's a more level where we can pretty much see what's going on. Also, the theory has ancient roots. Now, one thing important Brown was doing, and he didn't talk too much about it, he didn't talk at all, actually, but you kind of figure out. But he did say that it was important to have capacitors that could be charged and discharged rapidly. He didn't say why. The reason is because if you charge up the capacitor, its dielectric is going to become polarized. So it will develop an electric field actually opposed to what you're applying, and it will end up canceling out in this region, you see. So any initial force it creates will eventually subside because of the polarization of the dielectric. That's why his pendulums would first swing out and then gradually come down and have no more force. So he realized that to sustain that, he has to rapidly charge and discharge his gravitators. Now, somebody sent me an email in something he read in a book that Brown's work became classified after he began rotating his gravitators. I don't know, this was only a reference in one book. So I thought about this. I thought, well, what happens when you're creating a huge gravity gradient and you suddenly start rotating it? Well, you're going to create sort of a gravitational vortex. And what does that do? Well, in subquantum kinetics, the gravity, it's due to geons being consumed in the Earth, and they create a G gradient. And that's what's pulling us down. That gradient is interacting with the matter in our bodies. And if you have a way to spin those geons outward, then they won't affect your mass. And if you're going to be creating a vortex in a way that geons are coming down due to the Earth's gravity field will now get spun outward instead of coming down the way they normally do. And this could be creating a gravity shielding effect. So maybe they already knew about this. They didn't want Brown to be talking more about it. It's interesting now, this is a spacecraft Mark McCandlish drew based on an eyewitness report who saw this hovering at an air show in a hangar where only certain people were admitted. And are you all familiar with the McCandlish UFO? Yeah. It struck me just from his drawing that it looks very World War II-ish or 1890-ish. I wonder, is it really an alien vehicle that they captured, or could it be something that maybe it ties into some of these 19th century airships or even World War II airships? It's something to think about. I mean, I noticed the rivets. I haven't talked with Mark about this, but it's just interesting to see why would they use rivets. This seems like an old technology. And look at the design of the couches in the upper area, these air bottles. Anyway, the propulsion involves these capacitor plates you'll see at the bottom. These are capacitors, they're radial, and they divided them into like spokes. So they also have wires, copper wires going around, as I recall. So what this seems to operate like one of Brown's capacitor systems, where you want to charge and discharge very rapidly. So you do that with what's called a tank circuit, where you have the capacitor connected to a coil, and the energy, electric power goes oscillating between the coil and the capacitor. And if you do it the right way, you can get, so these are phased as they oscillate, so it creates a rotary motion of the charge. So not only you're getting lift from the capacitors, because in this case the positive charge would be up, but you get a rotary motion that could create a gravitational screening effect. This is just a suggestion, anyway. Now, this is Brown's electrokinetic apparatus. This works a little different from electrogravitics. He was flying these disks around a maypole in the 50s. He's doing this in Los Angeles. This is from around 1952. Here shows a slightly bigger disk, 2-foot diameter, charging the leading edge one charge and the trailing edge the opposite charge. And he got article in Los Angeles Times in April '52. This was around the time he was being investigated by Office of Naval Research. He probably did this publicity stunt to protect him from being classified, because then it would already have been out in the open exactly how he was doing this. One way to look at this is electrogravitically. If you put in positive charge on one side, negative on the other, he's creating a gravitational gradient, but it turns out that you can reverse the charge and it'll still go forward. That's why it's better to think of this in terms of electrokinetics, that what he's really doing is creating unbalanced forces, similar to the idea I was suggesting earlier. We'll show this later with the B2. Anyway, in 1953, around 1953, he came out with Project Winter Haven proposal to the Navy. Now, he was involved with the Navy, was with the Office of Naval Research before, so he had very strong connections. They highly respected his work. After all, he was in charge of this group of PhDs earlier during World War II. And he, around this time, also made a demonstration of his discs to Pearl Harbor admirals, which the results were classified at that point. In Project Winter Haven proposal to the Navy, he was proposing to build a saucer interceptor with Mach 3 capability. And he said just extrapolating the performance of laboratory disk prototypes that he was showing them, that he predicted you could create larger flying disks operating at electric potential of 5 megavolts, 5 million volts, that could attain speeds of Mach 1.5. And this 1953, so they just had broken the sound barrier just in the late 40s. So he was lowballing it to levels just a little more than what they were used to thinking about. And he said even Mach 2.4 would be possible with higher voltages and equipment then available if larger disks were built. And this would be in the upper atmosphere, he was saying, to get this high. Actually, these can go Mach 13 easily, in my opinion. So in the proposal, very important, interesting thing on page 3, if you read at the bottom, it says here, in recent years, as additional data of confirming nature became available, the research has been associated with government research projects of a highly classified nature or status, and publication has been precluded. So Brown's only publication was that Science and Invention magazine article. He never was allowed to publish in refereed science journals. And that's why I never heard of him till in the 80s. So unlike Einstein, Einstein did publish. They allowed him to publish, even Scientific American. Brown's papers were unpublished, even though his discoveries were far surpassed Einstein's and far more on track. Here, Brown is holding a 3-foot diameter disk, similar to what he flew at Pearl Harbor. And this is from a letter I received from Tom Terman, who was in contact with Brown in the early days, and they corresponded. And Brown wrote to him, showed this diagram, drew this diagram of the Pearl Harbor demonstration. And based on the angle he's showing, you can figure at least 11 miles per hour for the disk speed here. You figure the radius here is around 24, 25 feet from Brown's measurements. Now, if they were going, as Interavia magazine claimed at that time, that rumors said they were going at hundreds of miles per hour around the gymnasium, it would have looked like this at hundreds of miles per hour. These have been really out like this. We never know the truth because it's classified. Now, I decided to look at the air drag on this and got the standard equation for air drag. We know how much power he was putting in from his voltage and current. And you figure what power is required to overcome the air drag at a given velocity. It goes according to the cube of velocity, this equation here. So plugging all these in, you figure, suppose the velocity was 290 miles per hour, so that's in the hundreds, like Interavia was saying. Then Brown would have been supplying 6 kilowatts to power disks, but he was getting propulsion power 50 kilowatts. So over 8 times over unity. Now, even if these were going at 100 miles per hour, that would be, he would be getting at least 100% efficiency. Now, the jet engine is 30% efficient. So you can understand why these people were interested in this. Also, this doesn't take into account of the reduction of air drag. So if you take that into account, these figures wouldn't be so dramatic, because a lot of that would be due to reduction of the resistance, just due to the fact that the buffer, the field buffers the air, so it flows around it very easily. Now, in 1956, I discovered this report by going to the Library of Congress and looking through their card catalog for anything on electrogravitics, because at that time I just discovered about Brown's work and I wanted to learn more. They only had one card. It was for this report, and it was missing. So I had them do interlibrary loan search, and they were surprised that there was only one copy in all of the U.S., and that was at Wright-Patterson Air Force Base. So I thought, what the heck? So I did an interlibrary loan request from a local library, and they sent me the copy, a nice red outer folder. It's actually a red cover, so this hard paper. And it had been marked confidential, but somebody had marked it out with flow pen. So perhaps from my request they decided, well, this is old enough that we can allow it to be seen by the public. And I got hold of it, made 20 copies, and for a long time sat on it, and then I was handing to my friends copies, and then one time got together with Tom Vallone, and he said, you can't just keep this quiet, we've got to publish this. And so he had this, he put this in his book, Electrogravitic Systems, along with my paper on the B-2 bomber, reverse engineering. And then it's also in my book, Secrets of Antigravity Propulsion, in the appendix. Also, you can find it on the internet. So this was a think tank proposal or think tank report put out by a group in UK, 1956. They also were putting out reports to industry. This was going out to all the aerospace industry. And they were basically catalyzing the whole industry. Here it shows the Wright-Patterson insignia there. And these were company names that they were mentioning in the report that were working on electrogravitics. And they were blue skying us that this is the next evolution of aerospace, or predicting incredible future for everyone. If this continued, this was going to revolutionize air travel. And apparently it worked. All these companies had their own programs developing this. Around that time, Brown did further work in Paris, and we learned about this through a disclosure just recently, a couple of years ago. It's on my website. The Starburst Foundation site, starburstfound.org, has some forums. One is on electrogravitics, and you find it there. Here's discs that he was flying there in that project. They supposedly attained speeds of 35 kilometers per hour, about 20 miles per hour. He also did vacuum chamber experiments where he proved that this was not ion thrust, and these were very significant experiments. And basically, these are, as I mentioned, propelled by unbalanced forces. That the force, because it's creating a bow front, you'll see this with the B-2 in a minute. Now, one thing that came out of this disclosure of Project Montgolfier, the fellow who was involved in it, before he died, he mentioned about a letter of correspondence with other associates at that time, and they had found out that Brown, at that time, or after he'd left the project, this was immediately afterwards, was test flying a 10-foot diameter disk. This was real eye-opening. So here it shows that he was proceeding on his planned course that he had suggested in the Winter Haven project. And then sometime down the road, we find, well, Northrop testing, putting ions on the wing, and this is in one of the available periodicals. You can find this published. And then comes the B-2. Now, all this went black in 1959, at least, or shortly before, because here in this Canadian Aviation Journal, a story by Caro, he mentions how he can't get any information out of Glenn Martin, whether they've discontinued their anti-gravity program or made some significant discovery which has elevated it to super top secret category, since no information of the project has recently been available. So after that, you didn't hear anything about it in the media. So now, I believe that this was used on the B-2. There was a leak by some some whistleblowers who are Black Projects people, that the B-2 charges one pole, the leading edge of its wing, and the opposite charges it dumps in the exhaust. And here, in fact, you can see evidence of this in one Northrop video, which was later pulled after I had put it in my book, and they ended up pulling the video from the internet, because it probably showed too much. You notice the sort of glow on the wing, and then it went through a fog bank and sort of illuminated the fog. This is just in 2 or 3 frames at the very end of the video. So they pulled the whole video. Now here's from Brown's patent. You see he was proposing the exact same thing in 1965 in his patent. And here's his flame jet generator he was using to generate the power to power his disk. It works like a Van de Graaff generator. He uses the jet exhaust to carry the ions and thereby increase their voltage and collect them and cycle it back. And you can actually shut off the fuel and work this just on scooped air. And the B-2 does have huge air scoops. They say they dilute 10 to 1 the exhaust with the scooped air. So one way to look at it is through electrogravitics, that he's creating a gravity field that acts between the negative and positive charges that push the plane forward. Another is the idea of unbalanced forces that we saw in the earlier shot, that because of the asymmetrical shape of this, that this is the conventional field concept, would just produce stress, but when you realize that these charges are anchored in the air around or in the field around the craft, it's propelling the craft forward. And here it shows analysis of the forces that would occur on the craft just due to the electric charge repulsion. And it ends up that the forces are greater pushing it forward than backward. And the faster it goes, the more the Bow-Shock front of the positive ions slope back, and the more they're going to repel it forward, acting on the front. Here is the idea of the flux capacitor, as I call it, where you can oscillate the charges on his vertical thrusters. These were the vertical thrusters that Townsend Brown developed. He didn't put the coil on. That's an addition I made as a way of oscillating their charge. And by controlling the oscillation, you can control the amount of thrust. Now, I believe there's something like this in the wing of the B-2. The B-2 is loaded with thrusters in its wing, so it's not just what you saw there, pushing it forward. It's also able to hover motionless. And there's been sightings of the B-2 going either at very low speed, about 25 miles an hour, or even in some cases stationary. And people have seen the glow around it at night. So this studies what's called thrust-to-power ratio. The jet engine, which is the best we have, has a thrust-to-power ratio of 15 newtons per kilowatt. The Townsend Brown's barium titanate electrokinetic thrusters, this is based on his data that leaked out, it was 70,000 newtons per kilowatt. So 10,000 times, more than 10,000 times greater than a jet engine. And in terms of efficiency, would be this barium titanate thruster would be 140,000% compared to 30% for the jet engine. So if we wanted to go to Mars, we could make a spacecraft powered with Brown's thrusters. You can imagine thrusters 40 centimeters diameter, 20 centimeter deep, and put in about 6,000 of these into an array, nested array 30 meters diameter by 5 meters deep, and you could get enough thrust to accelerate this 21 metric tons, would accelerate a 100-ton spacecraft at about 20% the Earth's gravity acceleration, and would require propulsion power of only 3,000 watts, 3 kilowatts. And so it would, with this, you can accelerate fast enough that you could get up to speed, and the total flight time would be 5 days to get to Mars, not 9 months. If you figure the kilowatt hours involved, and you could do this with solar cells, works out to $25. The space shuttle main engine, 400 million, to get off the Earth. Now, for this thruster system, you'd have to start in space, so this wouldn't get you off the planet. Nasikas would, though, Nasikas thrusters, this type 2. So here's the flight path. You would get up to 200 kilometers a second within the first day. You coast, and then you decelerate. So here's a comparison to the space shuttle in terms of cost, 25 versus 450 million. And also this idea of buffering the leading edge of the wing in air travel. Now they started to use this on trucks. The inventors put this on trucks and you can reduce the air drag, and he's offering this for sale now to be put on trucks. This came out in Tom Vallone's Integrity Research newsletter. I found it very interesting. I think there's one person in the audience who's planning to put this on his car. Now this was, I approached NASA with these ideas back in 1992. They had a space exploration outreach program, and they didn't include the idea in their report. It never saw the light of day. They suppressed it, basically, or RAND, that was doing the project for them, suppressed it. But I went ahead and I contacted the person working on the next generation space shuttle, the space plane, and sent him a copy of my report along with the B-2 bomber paper I'd written, and a lot of information about Townsend Brown's work. And he looked at it and sent it back. Then he forgot about it. I contacted him again. And I said in a letter, this is a way to reduce friction, air drag, because you charge the leading edge of the wing. At least look at it from that standpoint, because they acknowledged that as a problem they were having. And this was back in 1993. And then you have the Columbia disaster. And so I wrote in 2003 to the Columbia Accident Investigation Board, said, look, I told NASA about this 10 years earlier, and they weren't interested. I got just a thank you letter back. That was it, So Now, Project Skyvault, we don't have much time here. I'll just quickly say that I learned about this from somebody I had met at a conference whose boss worked on this project, and he learned informally from his boss about it, some details. And then he also communicated by a letter with the person that was then working on it and learned a little more. And from those scraps of information, I was able to reverse engineer the technique, the technology, and this is described also in my book. It was carried out at Rocketdyne Corporation, based in LA, was able to loft craft on microwave energy beams, uses masers and phase conjugate resonator technique to create the beams. It uses sawtooth-shaped microwave waveforms. So instead of being sine wave, it's important to make them sawtoothed shape. It also uses metamaterials. These are materials with negative refractive indexes, which microwaves will exert a thrust on a metamaterial. So that was also incorporated, I believe. And this came out in the Smith & Smith thriller on CBS TV, 1996. They had an episode on something that was eerily similar. Although fiction, this actually, it was so realistic that I'm using this to illustrate the concept here of how they lofted. They originally had the beam generators on the ground lofting the craft. Eventually, they were able to put the beams on the craft, and now we have sightings like this, these triangular craft. I believe these are beam generators at the corners. And so basically, they're generating microwave beams. These are like poles supporting the craft. And this is the phase conjugate concept on the right. It's able to basically bottle up the microwaves into the beams so they don't disperse. You power them up, and energy stays there. And produce what's called a soliton. The two ordinary and phase conjugate waves produce soliton. And this is what the beam generator looks like. It's described in greater detail in my book. So somebody could take these ideas and recreate this technology. I believe the beam also, we have these in space. The beam was used to bring down the Twin Towers in 2001. Also, how you shape the wave is important. You can create attractive forces or repulsive forces. If you change the wavelength, you can cause something to fragment, like cement could vaporize in midair. This is Boeing has a metamaterial for microwaves. Why would Boeing be working on a metamaterial? They call it the Boeing cube. They don't say. And here's a sports model. I believe we use this technique. I don't think Lazar says everything correctly on that. So basically, we have unconventional ether physics used, and this is the last slide, finishing up, used to develop a secret off-planet civilization funded by deficit-creating black projects with no direct benefit to Earth civilization, seemingly, at least if it is, nobody has told me from the black projects. Whereas the sanctioned conventional physics that we're all fed through the media, which is incorrect, in my opinion. I mean, you must throw out most of what is taught in the universities. You know, the students pay $50,000 a year to learn. As a result of this physics, they develop conventional engineering devices, technologies, which are like earthbound, petrol guzzling, polluting technologies, rockets, jets, automobiles, and trains. So this is the Podkletnov thruster, which can theoretically develop light superluminal thrusts. Tesla had also observed similar effects in his work. I've worked with Guy Oblansky, and we measured superluminal wave transmission with pulses, charge pulses, which is similar to the Podkletnov thruster. Here was the results. We got up to 6.5 times C, close to the dome electrode. So with this, you could go to Alpha Centauri in 2.5 months, but it would take huge amount of energy. This is the trip. You'd accelerate to 200 times C and coast, decelerate halfway through. And it's, I guess this is really the last slide. So it would take 200 times the average power consumption of the US to do it. 4 billion terajoules of power. But who knows, maybe it can be perfected. Get that down. Yeah. But I think the Nasikas thruster is the way to go for these sorts of things. Thank you.
Dr. Paul LaViolette, one more time.